Hello everyone, we are recording this video to solve a Dritap Water Authority question on investment appraisal. You need to know the basics. You should have done some simple exercises, for example, DCF. If you don't know those exercises, then I would recommend that you go back and work on your basics and then come on this question. This question gives us a bit more scenario now, so it feels like a real life scenario. However, in reality, investment appraisal questions are a lot more complex than this. Dritap Water Authority is to provide a water supply to a new town development consisting of both industrial and residential units. The plans ranging over 7 years are as follows. So our timeline is 7 years. We need to keep that in mind. Land acquisition at the commencement of the projects amounts to £72,000. So that would be now when we start the project. Construction cost for laying the supply are $120,000, half payable at the beginning of the project, which would be time 0, and the rest would be at the end of first year, which is time 1. A pumping station will operate at the end of the second year, so that's timeline 2. The costs are estimated at $83,000 a year and will increase by 10% from year 3 and each year thereafter. 1,500 dwellings, houses will be completed in year 2 and further 3,000 in year 3. Each property will be charged £32 per annum, increasing by 8% per annum from year 4 and each year thereafter. And the last item is the forecasts are that the industrial estate will consume water at the rate of 2 million gallons from the beginning of year 3 and 3.5 million gallons in year 4 and 9 million gallons per annum afterwards. This will be charged for at 0.4 pence per gallon over the whole year. Not 4 pence, but 0.4 pence. So 4 pence is 0.04 pounds. So when you have 0.4 pence, then it has to be 0.004 pounds. Alright, so what we need to do, calculate the net present value of the project using discount rates of 10% and 20%, indicate the internal rate of return. So we haven't discussed internal rate of return. This is something which we will be discussing in this question. So our starting point should be to calculate NPV at 10%, just like we have done it in DCF, slightly more complicated though. So let's go to our Excel sheet now. So we have timeline. So first of all, we do 4 factors again. Now the difference between DCF and this question is how the timeline looks like. Now, in a very basic structure, our timeline is usually vertical. So in DCF, we had first column of DCF of timeline. That was a column. However, when a situation are complex, and mostly the situation are complex, our timeline is mostly is horizontal, not vertical. So we will use a row for our timeline and not our column. So whenever you have a complex NPV situation, or even not so complex, but there are more than one types of cash flows. That's the main thing. In DCF, you were given one simple lines for cash flow that in year 0 you're spending, and year 1 you're getting 1,000 and 3,000 and 3,000. However, in this question, you see that in the same year you're getting multiple cash flows. If you have a situation like this, then using a vertical timeline messes things up significantly. So you will see the benefit of a vertical timeline. Let's just drag it to year 7. It's a 7 years project. So there we go, 7 years. First of all, we have land, which is we are buying now. So start of the project would be time now. So whatever you spend at the start of the project, 72,000 now. And then construction cost for laying the supply are 120,000, half payable at the beginning of the project. So construction cost. 60,000 half payable now and half at the end of year 1. 60,000. So these are our outflows. Pumping station. So number 3, pumping station is going to cost us some money. Second year, at the end of second year, the costs are estimated at 83,000 a year. So second year, 83,000. And then they're saying that these will increase by 10% from year 3 and each year thereafter. So year 3 would be 10% extra than year 2. So what we do, we multiply this with 1.1. So this has taken into account the 10% increase in the cost. Now, if we actually simply autofill this, we will get it 10% every year anyway. So look at this. We have E4 and 1.1, which is 10% extra. Let's skip that and let's do the last one, and it's giving us the same 10% extra. So we have taken into account. Now we can actually total these up and get our total outflows. So let's put a sum there and autofill or copy and paste the formula, and we have got, let's put common separators here, but get rid of the decimal places. Let's adjust the width of the table. There we go. Now comes our inflows. So it says that point number 4, 1,500 dwellings will be completed in year 2. So dwellings, year 2, 1,500. And so 1,500, and we will be getting some money from them, £32. And in year 3, a further 3,000. So 1,500 plus 3,000, 4,500. And we are charging them £32 per annum. That's very cheap. Nowadays, it's at least £32 per month. For small flats, big houses pay more. And then we have increasing by 8% per annum from year 4 and year thereafter. So year 3, no increase of 8%, but year 4, yes. So year 3 income times 1.08. So when we multiply it 1.08, we are actually increasing it by 8%. Using the same logic, autofill, and we get this. Let's check the last one if it's actually correct. It is correct, so we just find it. So these are our inflows from dwellings. What is happening with the industrial estates? The forecasts are that the industrial estates will consume water at the rate of 2 million gallons from the beginning of year 3. Okay, so industrial estates, year 3. So 2 million gallons for the beginning of year 3. So 3 million, 3 6 zeros, 1 2 3 4 5 6 into 4 pence, 0.4 pence. So that's 0.004 12,000. Then in year 4 we have 3.5. So 3,500,000 times 0.004, and then we have 9 million gallons afterwards. So 1 2 3 4 5 6 into 0.004. No annual increase in this case, so it will continue at 36,000 thereafter. So we have outlined all of our cash flows now. So if you have a situation like this, you can only do a horizontal timeline. I will tell you when we can have a vertical timeline, and that is after netting off all of these cash flows. So what does that mean is that, first of all, let's have a highlighter here, a gray, and then another gray. Total inflows. So sum of all these two columns. We haven't got many columns here. Control C, enter, and net cash flows. So let's gray it out as well. And now we have net cash flows. So this would mean total inflows minus total outflows. Copying the formula, so we get total inflows and total outflows. Let's give it a nice color because this is an important figure. So if you have these final figures, then you can have a vertical timeline like in DCF. But if you have more data, then you have to do something like this. And you see from this stage, everything will look like with the four elements. We have one element here, which is timeline. The second element is net cash flows. The third element is discount factor. And in this case, discount factor, first of all, we are taking at 10%. 10%. So at time 0, value of £1 is £1. No issue with that. And then you go to your present value table and put the values of £1 under 10% for respective years. So 1909.826. I'll deal with these ones later. Let's just put this 0.751, 0.683, 0.621, 0.564, and year 7 is 0.513. 0.513. So it seems like all is 1, however, it is not. So let's increase the decimal places. 1, 2, 3. 3 is fine. So from here, as you see, if you have the net cash flows, which we had in DCF part 7 of that question, in this case, we had to calculate net cash flows. So now we have that. So we have net cash flows, we have discount factor, and we get present value, which is, is time discount factor times net cash flows. Control C and Control V, and we get that. And what we do, we net it now, net value, which is basically adding up all of these figures. So all of the present values. So let's go up there, select the whole range, negative, positive, everything together, press enter, and you get your net present value of 42,856. Let's give it a good, nice color, which is somehow not working. Okay, it's not working now. So your DCF could be done this way as well. If you just take into account the final 4 columns and the timeline out there. So that's the main difference between this question and DCF. Now, the question asks us to do it 2 times. One is at 10%, and then at 20%. And there's a reason for that, which we will actually come back to. But let's just Now, the good thing is we don't have to do everything again. We will start from this column, net cash flows. So let's just copy it and paste it here. I'll put the numbers. All right. And let's give it a heading that at 20% discount factor. So net cash flows are there. So let's do the discount factor at 20%. And let's take the figures from our present value table now. So going back to my present value table, 0.833 in year 1, 0.694 in year 2, 0.579 in year 3, 0.482 in year 4, 0.402 in year 5, 0.335, and last year's 0.279. Okay, so it's all being rounded up or down, so let's get decimal places, which we need, otherwise it wouldn't make sense. We multiply this with the discount factor, present value, and all we have to do is sum up. No, not yet. First of all, we have to multiply our cash flows with the discount factors. So we did that. Let's Control C and paste. And now we get net present value, which is sum up all the present values, positive negatives together, and we get a negative 38,397. If it's 10%, then the project is profitable. It's giving us a positive NPV, and if it's 20%, the project is giving us a negative NPV. That means project is not profitable. And the problem here is when we do NPV, we calculate our discount factor at the start. And the chances are that it would change in future over the life of the project. So let's say even if we had a cost of capital of 10% at the start, it could go up or down depending on that. Management is more concerned if the cost of capital is go up, because if the cost of capital goes up, the NPV goes down. So the cost of capital and the NPV has an inverse relationship with each other. They move in opposite directions. As is evident, cost of capital has gone up by 10% and the NPV has gone down by almost the same value. Now you can see that it's at 10% is positive 42 and at 20% is positive 38. Both figures are very close to 40. So my guess is that the break even, where NPV is 0, so we have done break even concept. So it seems like the break even of the project is somewhere in the middle of between 10 and 20, which is 15%. Now in discount value and investment appraisal, break even point is not used. It's called internal rate of return. The concept is very similar to break even point, where we are not making a profit or loss. But in this case, internal rate of return is the rate where we are barely meeting or only meeting our cost of the capital. And if we're meeting cost of the capital, the project is profitable. So from management point of view, it is important to know that what is the IRR of the project, because then they would know that how far are we from our current cost of capital. So The distance between or the difference between cost of capital and internal rate of return is kind of same as margin of safety, which we have discussed in our CVP analysis. So it is important. So let's say if the cost of capital is 10% and the internal rate of return is 15%, that means there's a 5% margin before this project would be not profitable. So the smaller this margin is, more concerned the management would be. And if the IRR is way above cost of capital, then management would be satisfied that it's a good project and there's a good safety margin in this project. So it's important to calculate that at the start as well. Now, to calculate the IRR, we need a formula, and I'm going to give you that formula now. Let's enlarge this. Internal rate of return equals, so R1 plus NPV1. What does this mean? R1 is one rate where we get one NPV. So R1 is 10% in our example, and NPV1 is the NPV which we got using R1, 10%. So these two needs to correspond, otherwise you will get it wrong. Divided by, so let's put a bar there, divided by NPV1 minus NPV2. Okay. And this would be multiplied with R2 minus R1. What was R2? R2 is our second cost of capital, 20%. And NPV2 is our NPV at 20%. Okay. So let's solve this now. So R1 is 10. Do not get messed up with percentage sign. You don't need this in this formula. NPV1 is 42. So let me go there and find this out. Control C, and on special place numbers, don't need that many decimal places, divided by NPV1, which is 42856 minus. So if you go to sheet 2, you get minus 38397. So minus, because formula has a minus and then the figure has a minus. If you, this is situation, minus and minus are getting multiplied. So when minus and minus get multiplied, they turn into positive. So we put the figure as 38397. Let me check, double check. 38397, yes. So 38397. The brackets closed. And now R2 is 20 minus R1 is 10. So now let's solve this formula. 10 plus, let's not touch this right now. And let's touch the middle bit now. So put the formula first of all. 42856 divided by brackets 42856 plus 38397 brackets close, press enter, and you get a value for this amount. Now we can solve this bit. This is 20 minus 10 is 10. Just need to remember that this is being multiplied with the figure before. Let's solve this a bit more now. Control C. I'll not touch this at the moment. I'll touch only do this. So now this will be multiplied with the 10. So let's put 10 there. and we have got 5.27, and now we can calculate IRR. Okay, IRR, internal rate of return, is 10 plus 5.27, which is 15.27. And now you can put a percentage sign because we have resolved the formula. So that's how you calculate NPV. You may be asked to calculate an NPV in a MCQ question, but not the full one. You'll be given NPVs of 2 projects and so on. So it is important that you understand this concept. So that answers the technical part of this question. The other part B of this question is asking us to calculate what other factors should be considered by the authority. Present the results in report form to the management board. Report form, it's important you understand how a report looks like. There are samples of the report on the blackboard, which will be very useful in your assignment, but I will discuss those later. But when we were discussing investment appraisal slides, we looked at the factors which needs to be taken into account when we are making investment appraisal decision. So these are normally the pastel factor: political, economical, legal, technological, environmental is very important in this case because it's water, and environmental factors. So these are the ones which needs to be taken into account. All right, so that's all from me on this, guys. Thank you for watching this video. So what we did in this video is we answered our NPV calculation using 2 formulas, and then we did internal rate of return doing this.